Hey, Mike here. Hey, I just wanted to point something out. I installed these temperature sensors, thermocouples, directly in these refrigeration lines. Did a few videos previously about them, and running at a really low temperature right now. Pressure is about 8 pounds per square inch, which corresponds to negative 25. But I wanted to point out temperature difference here. The first value, that's taken from this thermocouple, which is mounted directly in the stream of refrigerant. This last value here is taken from another thermocouple, which is mounted to the surface. And notice the difference between the two there. You got 12 and a half, pushing 13, something like that. So that's the difference between taking the temperature on the exterior of a copper line and the interior, at least on this high temperature superheat line. Something closer to ambient's probably not going to be as much of a difference, but I think it is notable though. And if you're trying to actually take specific enthalpy values, various points in the system, I think it's obvious that it's crucial that you take those values or take those temperature readings directly in the refrigerant line itself. Down to about 10 psi, which corresponds to negative 21 degrees Fahrenheit. Son of a bitch is cold. Fingers are sticking to it. I would say though that we're running a little dry if you consider where the frost line is on these things. It's neat though. It's fun just to kick it on and see it respond like that, being such an unconventional system as it is. The Ebullator. I can crack open the throttle just a hair. Oh, too much. It's very difficult to control. See a corresponding rise in suction pressure. Around 20 right now. Rising. 22. Negative 2.25. 25. 1.75 degrees. Rising. But we're getting a hell of a lot of superheat off the discharge. We're still running only about 200 pounds per square inch, which corresponds to 110 degrees condensing temperature. So a lot of superheat. Not a very high COP, if I had to make a guess. Pressure's pretty damn hot. Cooling water isn't warm. I tell you what, what's coming out of the discharge of the heat exchanger is a hell of a lot warmer than what's in there. So we're picking up heat fast, discharging it fast. But of course we're not insulated at all. We don't have anything holding back. Actually see the refrigerant bubbling in there, churning and blowing. Whether or not that level you see there actually corresponds to the actual refrigerant level inside the entire system, you know, from there to here, it's hard to say. As you can see where the frost line is on that one. Yeah, we're beating on her a little bit here. Yeah, according to this, this is 100 degrees. That's taken right here after the condenser and the receiver and everything. So still pretty warm coming back. Hell of a lot of flash gas. Likely a very low COP. What do we have here? Well, of course we cracked everything open, so probably have a lot higher mass flow rate. Here's some bubbling. Probably some gas actually passing through. We probably have a low refrigerant charge. I'm going to say we reduced the compression ratio drastically, but by opening that valve up considerably, we probably have a lot higher mass flow rate and a lot more refrigerant is actually vapor is returning in terms of mass. The little line here is relatively cold, so we're cooling the compressor back down a little bit. We had it restricted pretty considerably, so I don't think there was a lot of mass flow coming back to the compressor. Excuse me. You can see at that lower lower discharge temperature, the interior thermocouple and the exterior thermocouple, there's not quite the difference in them. But as it was dropping so rapidly, the interior thermocouple will decrease in temperature far faster than the exterior one. I'd love to see that on a live graph. Tone of the compressor changed considerably. Temperature on it. With my biologic temperature gauge here. Cooled down quite a bit. The frost has melted off. We're at a suction pressure of about 57 pounds per square inch, which corresponds to 34.5 degrees Fahrenheit. Moving a lot more heat, but at a higher suction pressure and temperature. Anyway, that's enough for this evening.